Alright, so we're going to convert this Princeton 1969 Princeton non-reverb aa964 into a Tweed Vibrolux 5F11. They're very similar already in the circuit. A couple of changes to the tone controls, and the tone stack gets eliminated, and a little bit of preamp gain differences, an unbypassed cathode resistor, and a few other things in the preamp. And then in the phase inverter there's a couple differences, and in the negative feedback there's some important differences that we're going to eliminate the old negative feedback and its method of returning to the preamp stage and take it directly from the output transformer secondary to the cathode, the unbypassed cathode resistor, or sorry, the unbypassed, cathode of V1B, the second gain stage, post tone and volume controls. So the new signal flow will be input jack to grid as is, and then we're going to lift this 100K slope resistor, lift this treble tone cap, and that will essentially defeat the entire tone stack. Then we'll pick that off with a 0.0022 coupling cap to the volume pot. Treble pot is going to go away, get replaced with a 1 meg tone pot that will connect to the volume pot, and the tone cap from the tone pot to ground, 0.005 microfarad, and a bright cap between them, which we may or may not keep, but we'll do it because that's the 5F11 spec. Then from the output of that, so yeah, that returns to V1B's grid, and the output of that is as is. It's fine. You've already got your coupling cap here, taking you to the input of the phase inverter. This particular amp has a grid stop added to the phase inverter input, which we'll get rid of and go straight to the phase inverter as per the Tweed Vibrolux schematic. Then in the output section, well, let's do negative feedback first. And a couple other things on the preamp side. So the second preamp stage after the volume pot and tone controls is not, the cathode resistor is not bypassed. So to kill two birds at one stone, we're just going to lift the wire that currently goes to the bypassed cathode resistor and connects to the negative feedback loop, and tie that off, and just take a 1.5K resistor from the cathode to ground, probably at the jack of this trim switch. We can just take it to ground there, and then that gets rid of our cathode bypass cap and our negative feedback injection point. So now we'll take the output transformer's secondary via a 56K resistor to the cathode of V1B, and that's how the Vibrolux gets its negative feedback. So that takes care of the preamp stage and the negative feedback, and now we're at the phase inverter, which is largely the same. There's a one different value here. Instead of 1.5K, it'll be 1K. And then that takes us to our coupling caps that feed the output tubes. These screen resistors will go bye-bye, but these actual grid stops that got added to this amp as a mod will stay, because that's part of the Vibrolux schematic. And then to get the voltages down to where they should be, we're just going to swap the GZ34 for a 5Y3 rectifier, and that should pretty much put our voltages where they would be on the Vibrolux. And other than the tremolo, which is still bias wiggle, it's just slightly different positioning of the oscillator and stuff, this will be pretty much identical to a Tweed Vibrolux circuit. Tweed Vibrolux did have fixed bias for the power tubes, just like the Princeton aa964. So yeah, that's the plan, and we should have a pretty true version of a 5F11 Vibrolux when we're done.